Hey everybody, welcome to our video. What is GIS? Well, to use GIS, you clearly need to have a mullet, bad posture, and be working on an ancient Apple Commodore computer. Not really. That was back in the 80s. We've come a long way since then. So GIS stands for Geographic Information System. So it's a software or a family of softwares that allow us to overlay and compare different types of spatial data sets. So that's really the theme, is that all the data we look at in GIS has some spatial element to it. It exists at some point in space, and often the point is to make calculations, spatial calculations. So for example, what kind of data could we have? We could have transportation layers, roads, streets. We could have state or country boundaries, maps of vegetation, maps of soil. We could have census data. Really anything that exists in space can be a layer in a GIS system. And we stack those layers on top of each other and then visualize and make calculations. So there's a lot of benefits to GIS. As I just said, it helps us quickly visualize spatial relationships. It allows us to store data with its spatial reference information, and then easily perform calculations across multiple data sets. So for example, if you want to know how many roads or what's the total length of roads in Addison County, you could easily do that by comparing, a roads layer with a layer showing the boundary of Addison County, for example. And then beyond calculations, we can also make excellent maps and figures that are customized to really show a lot of information. So we'll talk more about this, but there's two main types of data in GIS. That's raster and vector. So raster you can think of as being essentially a picture or a map. It's really defined by its continuous nature. Rasters have a value at every point within the image. And the data is typically stored in a grid of equally sized pixels. They don't have to be equally sized, but they often are. So that could be anything. That could be elevation values. It could be color values in a photograph, but it's always going to be continuous. The other is vector. Vector data tend to be discontinuous data, often represented by shapes. And there's really three main types of vector data: points, lines, and polygons. Points might be fire hydrants or houses. Lines might be streets or rivers. Polygons might be property boundaries or state boundaries or a land use type. And so by overlaying vector and raster data, we can make a lot of powerful calculations. So to finish this, I want to show you what this looks like in an actual ArcGIS software. In this case, I'm going to show you an example from QGIS. So here's my QGIS project. We'll talk a lot more about this, but in particular over here I have my layers. And these layers are on top of these other layers in the bottom. What you're seeing here is Lake Champlain. So I've actually outlined Lake Champlain with a vector polygon that I can turn on and off. So it's just a tracing of the extent of the lake. I've also got another vector layer, which is a set of lines delineating the rivers in New York and Vermont that feed into Lake Champlain. And then underneath this is actually a raster layer representing elevation. So I can turn that on and off as well. So that's a continuous, there's a value at every point in that raster layer. And then below all of that, I have yet another raster layer. That's actually an image layer. In this case, it's a set of satellite photos, which again have a color value for every pixel. And those colors are, of course, representing green trees or runways, so on and so forth. Thanks for listening, everybody.